Now let's switch tracks dramatically and go and look at recommender systems for a little bit and discuss those as another example, which are done in detail in the class. And here this summarizes why recommender systems are interesting. We need to match in many areas of lifestyle informatics, at least what I call lifestyle informatics or e-commerce. We need to match items to people. If you log on to Amazon, we need to tell you which things you want to buy. If you log on to Netflix, we want to tell you which movies to look at. And we want to therefore personalize the matching of items to people. Um, and here are some examples here. People to products, that's Amazon. People to people, or Netflix. People to people, that's social networking. LinkedIn keeps telling me what people I should add to my network. If I want a job, I go to Career Builder or Monster. Then I'm matching people to jobs or employers. Then we want to take people, the most important, and perhaps the earliest example, namely we want to take people and queries and match them to the web and give the people a subset of the web they're interested in. In each case, we're taking a set of things, products, people, jobs, web, and we're finding the subset of those things which match to a particular person. So that's what a recommender system is. It does that. And there are many different technologies that can be and are used here. There's no single solution, but you can say it's a broadly incredibly important technology. And probably the greatest knowledge of this field actually lives in industry. It is not published because it's too important. Amazon did publish a paper in 2003, but they haven't published a recent paper, I believe, on their recommender system. And I'm sure it's changed drastically since 2003. So here, this basically tells you things I've partly said already. So we have these recommender systems which make suggestions in real time, and as well as movies. We can eat at restaurants, we can go to events, and we can, I've already mentioned music. Another example is the Google News page. It chooses which news to give you based on your preferences. If we're running a supermarket, we need to take sales statistics and decide on discounts. And also we need to decide which items to put next to what other items. We mentioned identifying colleagues on LinkedIn and matching employers and employees at job sites. I notice everything is an optimization problem for the Higgs boson case we did before. We had to identify the Higgs from the data, and then we actually fitted a model to the data, which was a Higgs, represented by so-called probably a Gaussian distribution, which was the little bell-shaped curve, and then a background, which was the sloping curve. And so we needed to optimize that model, and then the size of then you looked at the size of the part of the model, which was the particle, and you decided on that what the so-called cross-section or probability of producing a Higgs was. And so that's an optimization problem, fitting that model to the data. If we're matching a user to jobs or books or other uses, that's an optimization problem. We want to find the best jobs for a given user. Another aspect of optimization is classification, which is optimizing the assignments of members of an ontology, and an ontology is a list of categories to data. And one is always trying, in these optimizations, minimizing some function or maximizing the negative of function. And there's a lot of effort goes into both the method for the minimization and also for deciding on the function to minimize. In physics, it's relatively clear what you minimize, but in some of these areas like Netflix movie recommendation, exactly what you minimize is not obvious. In fact, what you're trying to do is you're trying to maximize the long-term business success of Netflix. You're not even trying to find the best movie for the user. You want to find the movie for the user, which will ensure the user will come back to Netflix and continue to use Netflix's service for the next few years. As we look at this, you'll find that most of these problems will be thought of as thinking of people or items as points in space. These are usually funny spaces with high dimensions. And sometimes the space has got a bag, and the so-called bag of words model for information retrieval. When you think of documents as a set of words, and then you have a space where each dimension is a particular word, and then you characterize the document by which of those words is present in the document and the frequency in which they occur. So that's a particular vector associated with each document. This slide comes from a tutorial from Netflix on how they do recommender engines, and they have different ways of coming up with suggestions, and they have to bear in mind that they need diversity, because for Netflix they have multiple people watching movies, so you don't want to give everything that dad wants. You want to give dad, mom, and children's interests in maybe even the dog's interest in what movies. And so they try to have diversity, because maybe if they did a pure optimization, they'll only find dad because he maybe spends more time than anybody else, and they will miss out the dogs, what the dog wants to look at. And they say there are various criteria, because when you think of these optimizations, you can optimize for different things, and that's a very important aspect of optimization. Usually they're multi-objective, and each objective function, each measure of happiness has possibly a different, typically a different optimization. So Netflix says it is basically a recommender engine company. So here's this assertion here from Netflix: everything is a recommendation. And they obviously get you want to make it automated, but they also want to put in the feedback from the user, and they have explicit data and implicit data implied by exactly what the user does, as well as the explicit rankings the user puts in. And I pointed out why they needed diversity, so that they don't focus on too much on one aspect of the viewer in that household. So this is a complicated problem, and this whole problem, as far as I can see, has just happened over the last 10, 20 years, because previously such things were not important, and but recommender engines have become critically important over the last few years. Here's some measure of the size of Netflix. It was sort of interesting. Again, this is the issue of big data. Users do 4 million ratings a day, and it's those ratings are the simplest way. You use so-called collaborative filtering to make predictions. The users do searches. What they search on gives you information. What they play gives you information. And you can see that Netflix did 1 billion hours a year ago, June 2012, and in April 2013, they got 29 million subscribers. Here's the competition I mentioned. This is the one the student teams were competing with different methodologies. But here's a bunch of professionals. Unfortunately, they're all male. And this particular bunch got their check for $1 million because they got the best improvement, and which was the 10% improvement. They had to get them. You got some workup prize if you were the best, but then when you got your 10%, you got your $1 million prize. And I think it involves some 100 different algorithms in a complicated mixture to try to really make the best possible prediction. And if I remember rightly, Netflix did not tell you the answer. They just took it, and whether they ever used it, I don't know. Here I put this on because Netflix has the concept of consumer data science. So it says that Netflix has endorsed data science, and that's what this class is about. It's an introduction to data science, and everything is done by empirically. Namely, if they want to know if a given idea is any good, they just take a sample, an appropriate sample of the consumers. They run the new algorithm on those consumers to compare it with the existing algorithm, and they're always running these so-called A/B testing on their system to try to keep on optimizing algorithms. So this is the fourth paradigm. Let the data speak for itself. Notice Netflix doesn't have any sort of fundamental data. It's not described by Newton's laws or anything. Its basic data is the action of users, how they rate movies, what movies they watch, and what they click on as they move around the Netflix site. That's the information they have. So this data is a very empirical data, and you could say it's not very fundamental, but it's what underlies this part of the big data revolution.